Hey all, this is the News Recommender AI assistant that I made to obtain fairly consistent news classification according to my reading interests. So I was overwhelmed with things to read every day, like more than 60 articles a day coming right to my email address. And then I thought I could use AI to create those a bit further and even highlight the best of the week. With that, I've obtained fairly consistent news classification as we can see. My name is Douglas. I'm developing for the web with TypeScript for 5 years now at CodeMiner 42, and I'm currently allocated as a full stack developer at GoDaddy, and I'm pragmatically using AI to ease my life. What do you see here? I made a POC AI assistant to help me prioritize my readings so I keep up to date with the topics I'm interested in. And how is my FOMO satisfied? Maybe. So the requirements to follow this talk, I need you to have a general knowledge on what LLMs do and perhaps how they work, such as on token prediction concern. You will need to know thus what tokens are, such as everything that goes in and out of LLMs are tokens, and what is the context window of a model, which is roughly how many tokens you can send and still leave room for the LLM to work and respond. The rationale of this experiment. Why would we use AI to tell us what to read? We sort of already do, but it's out of our control. Social networks already have recommendation algorithms of their own to recommend us videos or things to read. But for professional development and continuous learning, we gotta stay up to date with news and trending topics on our area. To properly achieve that, we gotta curate what we read. We just have a few hours a day to catch up with everything, so we end up signing up for newsletters, right? Newsletters are basically curated news set arriving at our email addresses sometimes on a daily basis. For example, Y Combinator, TLDR Tech, and Daily Dev. Those are news normally curated by humans, so there's a bias already on that. But at least me, I still sign up for more that I can read. How LLMs could help us on that? LLMs are good for summaries and they can infer meaning from a block of text. So maybe they could roughly classify a news article, such as extract the meaning of a news summary and compare with the meaning of this summary with the meaning of a preference I passed as a context. Before I show you the implementation that I made, I have a disclaimer. After working on this POC, I got some feedback from specialists. And long story short, GPT is good enough to classify general meaning, but hallucinates often. And a way more precise but more limited strategy would be to use a BERT model. This would leave me need me to do some more work because BERT has way shorter context window in general, requires training, but it's lighter and way more precise. So this is one of the possible strategies to classify news articles. For the first step, the building blocks. I recommend you to start by reading the quick start docs on the platform, OpenAI docs. That it basically creates a client from the OpenAI class and accesses the responses API to create a response using the GPT-5 model and phrase as an input. I did similar thing. I just created a client to be reused across many prompts, and then I exported it to use, for instance, this prompt last week file that I have uses the same responses API, but instead it's using the GPT-5 mini model. Notice that along with the model, there is the input and also the text format. The input, we will look at it in a bit, but I want to focus on the text format now. There's a pretty handy tool to force the input, the output to follow a certain format, a certain schema that you can declare. In this case with Zod, If you don't never tried Zod, I recommend you to do so. It's very easy and very useful, very handy to use. I define what is a ranked article to my needs. It's not an OpenAI, it's not a AI thing. I just declare an object to my needs, which includes a title, a rating. The rating will be from 1 to 10, a link, and the explanation the LLM will give me on the rating it gave the article. The response I want to be several articles, so I made a object that the response must be an object. So I added a property called articles that is an array to be a collection of ranked article. To use that schema, there is a utility that is exported by the OpenAI package itself that accepts a Zod schema and sends that to the model so the model can when generating the response, it will use that schema to format for you. So you don't need to beg the LLM to respond in a certain JSON format. It works sometimes, but it's not the best way to format your responses. So let's take a look at the input now. The input I made here is divided in three parts, being the system prompt, the developer prompt, and the user prompt. So, uh, looking first at the system prompt, it's the base knowledge that we will give to the AI. So the AI has some context other than the training context. So it bases the responses on the data we sent before. In some cases, the developer role, the developer prompt, and the system prompt, they are the same. You won't find those split. But in this case, for the model for Omni that I was using at that time, uh, it used both roles to work. So the developer role is basically the first instructions other than the system that you give to a model. You should tell how they should behave, what they are in the world, or the instructions on what work, what piece of work they should do. In this case, I'm basically instructing the model to rate an article based on time importance and yeah, basically how important is an article being one, I should defer the reading or 10, I should read it right now. It's basically it, but I'm gonna say in advance that it's not the best way to structure your prompt. Reading this article here, does prompt formatting have any impact on LLM performance? I've noticed that plain text does not always perform the best, especially in logical tasks. So I've decided to replace my prompts with formatted inputs. This article suggests that YAML or Markdown or JSON, depending on the task, they perform better than the plain text. So after some suggestions, I've refactored the prompts. I've merged both the developer and the system prompt into one prompt, being the system in this case. But instead of a paragraph, I've wrote a list of things the AI should do or behave as. Also, along with that, I've included the knowledge base on a list that I've gave a title called Articles to Analyze, and then the instructions on how to create those are the ranking criteria just below that. The user prompt also suffered the same refactor to be a list to be clear for the model to understand. Taking a closer look, yep. And also this, notice that there is a function to format the articles. Before I was using a JSON stringify formatting, but that wastes tokens. The JSON formatting is not the best to structure the articles that I have. So after some feedback as well, and after some iterations, I could find that structuring them in a more human readable or markdown-like structure like this it works better. Yeah, closer look on the uh, user prompt. Basically, reinforces the instructions on the system prompt, such as the 1 to 10 ratings, and plus instead of one important thing that I done here is the instruction on how many articles should it rank. Such as I'm gonna for the this prompt, I'm gonna send about 300 articles. That is the articles that came to my email address from the last week. I'm instructing it to rank the top 20 at the minimum. If there are very important articles, more than 20, such as rating 7 plus, you should include them as well. I don't want it to return like 7 or below. I just want at least 20. Doesn't matter the rating. And if there are many 7 plus, I will want them as well. If I don't give this instruction, also the model complained that it doesn't know if I want to rank all the 300 articles or if I want for it to rank the top 20 or top 10, for instance. So that's the very important point. So it limits the amount of data it outputs. As we might already know at this point, outputs are charged in tokens. So if I ask it to rank all the 300, but I am only interested in the top articles, the most highly ranked, I'm wasting tokens ranking, returning the ones that are ranked low. That's a important point. Second step, uh, we need to build a knowledge base. We already have a spoiler. We had a spoiler previously because I already showed how the knowledge base looked like. So we will start here. Now, my goal was to obtain many articles, news articles that were structured with title, summary, and a URL to read the full thing. So I started collecting a huge collection of articles that comes to my mail address on a daily basis. And yeah, I ended up collecting a lot of articles, each looking somewhat like this, title, summary, and URL. By the way, the LLM will use the summary to infer what the article is about. So the summary, I think, is the most important part. Another example. So yeah, now let's go to the third step. By the way, how you obtain your knowledge base is up to you. You should create it with your own creativity. So sending that knowledge base to the prompt context we already saw, that basically we fetch from somewhere, is structured for the system prompt to use it, format it, and then it will be part of the system prompt. Let's then switch to the code base to see how it behaves. This is the repository of the code. I've created a few scripts like for to run a prompt for today or run a prompt for last week. And even I tried running a prompt for the last month, but that didn't work because the context window was too large for the model to attend. So yeah, basically, how do I do this? We'll show you the prompt for last week. The prompt for last week, as we've been seeing on the presentation, formats, grabs the last news that I have on my client here. I assemble a knowledge base, pass it through a formatting, then I structure the system prompt. System prompt will assemble on demand or like dynamically the articles of the past week, assemble some criterias, uh, the same that we saw on the presentation. We'll keep the same prompt as with the user. I pass the text format with my ranked articles schema. Then I will use a dates abstraction that I made to grab the dates. And yeah, let's run it to see interesting stuff. Takes a while, by the way. It's fetching by date. So the news that I received on the September 22 to 26. While it fetches, by the way, the source articles are stored here for now. I have been storing for a few months now. So it unfolds in a very interesting topic that I will show you in the next video. Good. So the response came. It parsed 23 articles. It selected 23 articles from the, if we look here, 65 times 5, around, yeah, a lot, like 300 articles were passed to the model and it selected 23 for us to read. Let's take a look. All right. First thing, let me show you the response, how the response looks like. It's pretty interesting that using GPT-5 mini that has reasoning, GPT-4o mini didn't have reasoning, so the performance is better even uh, for this case. What I want to show you is this, the usage. So basically, it charges everything that goes in and out of the LLM will be charging tokens. So it charged for the input tokens 40, almost 41,000 tokens, and it used uh, 5,000, being 2,500 the reasoning tokens. Total tokens of 46,000. Yeah, that would imply net cost. If I recall correctly, yeah, every model has a price of in and out. Like input tokens will cost a amount such as 25 cents a million tokens, and the output tokens could be like $1 a million tokens. We will show you in a bit how much this operation did cost roughly, but basically it charged for a million tokens, 25 cents divided by a million tokens times 40,000. It is not a lot. It's pretty cheap. And also $1, which is starting to get a lot, to be a lot, but since it outputs very few tokens, like 5,000, it's not a lot. This is the response. The response that was structured that I required is here, and the response.text, recall correctly, output text also holds the response. So notice that it is an object with an articles property that it has an array with the format that I specified. I wrote a parser to extract this to have a formatted JSON so I can read. And this is how it looks like. So it ranked 10 here, 10, 9 here, risks of NPM, which is pretty relevant at the time of recording this recording. NPM caused some pain in the environment, in the development environment. Rated 9, so it's a must read. We as developers must know what happened to the supply chain attack. Yeah, so it's pretty relevant. And yeah, if we see here, it ranked 1, shouldn't have included this rank 1, but the, yeah, said that it's a duplicated entry, so it ranked lower. Shouldn't have even responded this. So the prompt might benefit from some tuning still. But yeah, this is the point. Some news that were ranked lower than 7 might not be as interesting. We could invert the prompt as well to exemplify that news that are not important for us to read, but that would be a waste of tokens. So the whole point is to highlight the good ones. I've also run it once more before, just to compare the consistency of the outputs. For instance, here, risks of NPM was ranked twice, the risks of NPM. So, and this ranked as a 10, this one ranked as a 9. It's not the same, it's not deterministic, but it's close enough, I would say. Uh, the postmortem news here also appeared on the two of them, and down there, yeah, the duplicate entry didn't get selected. Yeah, that's pretty much the points that I wanted to show. The cost of each operation, this one costed 44,000 tokens, while this one took 46, pretty consistent. The outputs of the higher ranks are somewhat consistent as well. And yeah, uh, I think I think that's a good demonstration of the power of using LLMs to select. To improve this, I think we could touch a bit the prompt. I was trying to iterate with LangChain and using some other strategies to have consensus between many prompts and many models, perhaps. So we have more variety of outputs analyzed by a central model. That's another strategy that we can take as well. But yeah, basically it's a matter of tweaking these prompts here now. By the way, to correlate with I was saying before, the price per input token and output token, for instance, GPT-5 mini is 25 cents a million token for input and $2 for the output for million tokens. GPT-4o mini that I was using before is way cheaper by 15 cents for input tokens and 60 cents for a million of output tokens. So doing the math, it's is still relevant and it's still cheap to use GPT-5 mini because I'm spitting out like 5,000 tokens. So it's not that much. Would charge $2 if I would output uh, 1 million tokens. So just FYI, when you're gonna work, select a model, you might ponderate which one fits your needs and fits your pocket as well. So where to next? Uh, so perhaps I would profile my interests, exemplify the articles, separate them, the articles that I like and the ones I didn't find anything relevant. With that, with those articles extracted, I could work on a few shot prompt. The few shot prompt would be I manually would rank an article according to my criteria, and the model would try to replicate that judgment. Or lastly, I could try to train a BART model that would be like state of the art technique to recommend news. Also, those articles are pretty interesting to read. The second one is the one I read after building this project that showed me that I wasn't crazy by trying to classify news or recommend news or categorize news with a LLM. We used to use neural networks to match user preferences with news articles, but now we are starting to use LLMs to that task. Reading this article gave me some insights on where to improve. And also, recommend you try to interact with the OpenAI platform. Try to create a node project and interact with the SDK. It's pretty interesting. And yeah, using a cheap model is not that costly. I think that's it. Thank you, everyone.